So what we do is we make drying systems post-harvest for cannabis flower. We started in the food industry doing cheese aging rooms. We then went on to charcuterie for meat, and those use the science called water activity, bound and unbound water. And we thought there'd be a good application for it with the cannabis flower, which led us to trying and testing flower. And people then said, this is some of the finest flower I've ever had. And that led us on the search. Why? What's happening? And then working with the CRC, Cannabis Research Coalition, Dr. Allison Justice, determined that flower that was dried using our technology, the VapoTrol technology, as compared to legacy systems, which are repurposing air conditioners, dehumidifiers, we had 16% higher terpenes. And that's led to, that's why everyone says this is some of the best flower I've ever had. So then we were like, okay, now we need to understand the science of why are we getting higher terpene retention compared to legacy systems that are using this repurposed HVAC equipment. And we started getting into the trichomes, the cuticles, and through microscopy found that almost 30%, 25-30% of the trichome heads using conventional dry then cure, they were ruptured. And there goes all your terpenes. I mean, the whole purpose of growing the plant is for the trichome heads, because that's the factory that makes all the good stuff that we want out of the plant. And they're being damaged with conventional dry cure. And that happened out of necessity. You know, if you grow a plant, you can't smoke it. It's too wet. And if you go to store it, it's going to go moldy. So necessity said, hey, we need to dry these. And there are some places in the world where the weather conditions are right and it's going to work. But very often it could be a rainy day. The climate is wrong because you're in a different part of the region in the world. So then people said, I'm going to put it in a room with an air conditioner and help dry it. I need dehumidifiers to help remove the moisture. But there was no real science behind what was going on, and the science of water activity, which expresses bound and unbound water. And so what we're about is getting rid of the unbound water that mold and microbes grow on. Once there's no longer any unbound water, you have a shelf-stable product. And the food industry, the pharmaceutical industry, they're all interested in product shelf stability, not harming the consumer, but they don't want to take out one extra molecule of water from their product because they sell it by weight. And what we're finding in this industry are people are over drying because they're using legacy methods, using the air conditioners and dehumidifiers, and they're over drying so that they don't get molds, versus using a science of water activity and nailing it. But the difference is their technology that's being used currently with air conditioners, dehumidifiers, constantly remove water. So when you buy a dehumidifier, it's rated in pints per day, which is pounds per day, okay? And every pound of bound water you remove is 1 pound of top line revenue you just threw out. And with our technology, it's sort of like sous vide. If you've ever cooked with sous vide, you just put the flour into one of our units or one of our rooms, and we scale to thousands of pounds, and you put the flour in there, it's gonna dry and come to equilibrium with the space. Then you can leave it in there days, weeks, or months. So you no longer have the labor of, we got to arrest the drying and we got to take the flour out of this room or it's going to over dry, and then put it into turkey bags, totes, sealed containers. And then if you didn't remove all your free available water, it's going to go bad in those turkey bags containers. So what did people do? Burping. Burping was to release that excess vapor pressure should it have been taken too soon. We eliminate all of that. So all of that labor is gone, the guesswork is gone, because we're using the science of vapor pressure to get the flour to where you want it with the right water activity.
Are operators open to new science?
They are. What we have is a little bit of a tug of war. Given the economics of the industry and what's going on, we will get cultivators who struggle with their post-harvest every day in their facility. And they say, we need this technology. and they bring it up to management and say, we got to install this, we got to retrofit our rooms because this is going to reduce labor, this is going to improve our product. People who use it get brand loyalty from consumers. They keep wanting to go back and buy more of that flower. It is so good. So there's all of these pluses, and they go to upper management and go, nope, we're on a spending freeze. We have no money. You just keep doing what you're doing, live with it. On the other hand, we'll get people in management and they'll go, we need this. We need to improve our margins. We need to cut costs. We're willing to invest in this. And then they go and talk to their cultivators and they go, nah, I've been doing it the way I've been doing it for 20 years. I don't need any of that fancy whatever. So that's the conflict we get. When those two meet, we turn businesses around. How do we determine an ROI? What we look at is we take a sample of their flower they're currently packaging to ship, and we measure the water activity. And we have a table. You only need to dry to a 0.6 water activity. That's when you removed all the unbound water, and now you have shelf stability. Mold microbes can't grow. And they're drying instead of a 0.6, 0.5, 0.45, and that we know what the percent of weight they took off. So we're looking at 5-6% of their weight is lost due to over drying. Now, do the math. Take that number, multiply it times your top line sales of flower, because all your inputs remain the same. You grew the plant, you put the labor in, your nutrients, your energy, everything like that. You got your post-harvest, and now you're removing weight, saleable weight, that there's no reason to remove. So that's the upfront ROI equation we do. But then we can't put a value on the labor of moving, handling flower between the dry room and the cure space. We're one continuum. So that labor piece just goes away. Everyone's got different labor rates, so we won't. Now, what's the value of now having a far superior quality product on the market that consumers keep coming back for more? How do you put a value on that? So we don't put that value. So we really, when we look at ROI, we're just looking at lost revenue due to overdrying, and then anything you save on labor, on customer stickiness, because they like what they got. Those are hard numbers to put on it.
Does the industry have an issue with shelf stability?
I believe so, yes. I mean, how often would you go into a dispensary and buy flower and it's over dried and it's dust? Yeah, so what we've now is expanded our product line from the home dry cure units, which then we do all the way up to large scale, huge facilities, multi-1,000 pound rooms. Now the technology is being adapted for storage. So now we're getting people who are manufacturers who don't necessarily grow their own flower, but are buying flower on the market. And what they're doing is they're putting it into rooms with our technology to homogenize and get the water activity across everyone's flower that's coming in, especially those that are over drying. We have places that are looking at arbitrage. They're buying, bringing in when the price is suppressed, sitting on it because you can now hold it 1, 2 months, 3 months, and when the market comes up, selling it. Another use of it is pre-rolls. The pre-roll machines are very finicky about the flower. And what we do is we give manufacturers the ability to have consistent flower day in, year round. So once they set their machine, it just runs. Versus from batch to batch, they got to fiddle with the machine to run it because this batch is a little dry coming in, this is a little wet. No, we eliminate all of that.
No, that's one of the biggest issues in the industry when it comes to automation, right? Is just how variable the material is.
Right. Okay. And we take that, we just eliminate that.
Well, thank you very much for taking the time, man. I appreciate it.
Thank you.
Great job, man.
All right.
Crushed it.